Okay, let me go on rapidly. Novamont, what is Novamont? Just two words about the present situation. Novamont is a knowledge-based company, and we have 25 years of R&D experience in bio-based products. And today, we spend 6.2% of turnover in research, 20% of employees are in research, but almost all the people of Novamont are passed through research. About 1,000 patents, and in 1996, Novamont was a research center. Today, we are around 135, 140 millions of euro, 253 people directly employed by Novamont, but we have a range of startups connected with Novamont and the joint venture of Matrica, and altogether we are today 500 people. Another point that I want to stress about the knowledge-based economy, we trained 250 people up to 2,000 up to today, and this is a very important aspect of Novamont activity. Just words about the origin. The origins, we started as a research center, and this is in the DNA of our company. And we started in a multinational from the chemical sector, Monte Edison Group, and in the moment when it was acquired by Ridania Bedinsei, which was a big agro-industrial conglomerate. So we had, in 1989, the possibility to start to work in this sector. So we are a pioneer in the sector of bio-based products. When we exited from Monte Edison Group and as a research center, we started to develop our own business, trying to transform ourselves from researchers to entrepreneurs. We tried to apply a model, which is what we call the biorefineries of third generation, which integrate the technologies in to transform bio-based products in chemicals and bioplastics. And our main objective at the beginning was bioplastics. And the idea behind was to try to use local resources. It means local low-input crops, scraps, and whatever is possible to find in local areas, to try to respect biodiversity, to use marginal areas possibly without using a significant amount of water, trying to reuse the industrialized sites, and it's to integrate a range of technologies, multiplying the multidisciplinarity of the activities, and trying to connect the technologies in upstream integration for the chain of bioplastics. And the other element which was very important in this concept, it was to try to create new type of relationships between agriculture, farmers, and industry, because in bioeconomy, we cannot just speak of bio-based products, so we have to think about systems, and we have to think about territorial regeneration, otherwise we will not create jobs, opportunities, new type of sustainability for the local areas. So this was also the aim of the project, and you will see in my presentation what we had done. The product, we started with one product, which was Matter B, which is Matter B. It's a range of bioplastics, biodegradable and compostable bioplastics, and which are according to international standards. And which was very important for us. It's a long years of development of the technology, and the technology is a chemical technology in this case, to produce azelaic acid, and as you will see, also other type of chemicals, is an oxidative cleavage of vegetable oils without ozone. At worldwide level, azelaic acid is produced in the United States in one plant, quite old, and using ozone technology, which has problems from the point of view of energy, so not very useful for Europe, and also from safety point of view. So we developed a completely new technology, which starts from vegetable oils, using water, hydrogen peroxide, and air as oxidating agents. And through this process, we build the entire technology, which is quite complex, in reality 14 different steps. And through the development of the technology, we were able to create the joint venture with a petrochemical company like Versalis. It's a very interesting cooperation because, as I said, we need a lot of partners in our trip to create a fully integrated biorefinery. In this case, it's very interesting, this type of cooperation, because in one side we had the petrochemical industry, which had a deindustrialized site like Porto Torres in Sardinia, with a naphtha cracker, so with economical and environmental problems. And the interest of a company which is in the normal chemical industry, the real interest, the genuine interest for innovation, trying to find connections between this type of new products and the more standard products. And for this reason, we started the joint venture. The joint venture needed for the build-up of the technology 190 million up to date. It employs today 120 people, and they will be 145 for the end of the year. The indirect employment that we had created in the build-up of the plant is average 400 people, with peaks of 700. And the objectives are mainly the reconversion of this industrialized site. But it's also important not to create a cathedral in the desert. So it's so important, it's fundamental to create the connections with the local areas, and so the creation of a specialized chain from the point of view of crops, which can survive in an environment like the northern part of Sardinia. And we have also created a second research center in Porto Torres with the big pilot plants and new people engaged from university, which is giving a lot of positive things. What we are producing in these plants? They are 3 plants. The first one, you see the 3 blue blocks. The first block is the most important part of the process. So in this case, with the oxidative cleavage of vegetable oil, we obtain azelaic acid and pelargonic acids, which are not produced in Europe at all. These are building blocks which are useful for bioplastics, but are useful for a lot of different applications, as we will see. And on top of that, we have proprietary molecules which can be converted in a second plant, which is the one we call polymers and rubber additive plant, which is able to create a chain plasticizers and oil extenders for rubber. These are proprietary products. So we have proprietary technologies for producing azelaic and pelargonic, which are known molecules, but with limited production worldwide and with problems of process. From the other side, we have innovative proprietary molecules which are useful in interesting sectors of traditional plastics, where we improve the characteristics of traditional products. And then we have a normal plant, 2 lines for esterification, which permit us to transform the long chain C5, C9 esters in acids in esters of different type for different applications. how we can contribute with this type of products. These products can have very interesting opportunities because they can contribute to the quality environment. In what way? For example, the polymeric plasticizers are a replacement for phthalates. We can consider that phthalates worldwide are 5.5 million tons, and the problems of phthalates are known, and the discussion about phthalates in different member states, also in Europe, is quite clear. So this type of products can give a possibility at European level, but also in Sardinia, but also in Italy. Then biolubricants. Biolubricants are, we can produce intermediates for biolubricants, which can give higher lubricity, can contribute to biodegradability, and especially can give a contribution to low flammability. We can remember that lubricants are another big sector, 5.2 million tons, and we know that some areas of these sectors create a normal dispersion of oils in water and soil. So, and every year we are accumulating this type of products in soil and water. So this is another possibility. Then these products are not coming from palm oil. As we will see, we are studying the chain, the agricultural chains, how to obtain these products. So they can be palm oil-free components for cosmetics. And then, as I said, oil extenders for rubbers is also very important because oil extenders in the past were aromatic. Today can be instead they are lower impact still from petrochemical industry. In this case, we can put together the environmental aspects of the product itself, but also the improvement of the performances of rubber, because the rubber becomes a low rolling resistance and so decreases the fuel consumption and CO2 evolution. Or bioherbicides. Pelargonic acid is a bioherbicide. Some words about the chain. Thistle is the type of crop that we developed more. We are studying a lot of different other crops, but this is the crop that will be first to feed the chain. In this case, we studied the quality of oil, and today we are able to use this oil also for the process in Porto Torres. It was not so 2 years ago, to be honest. And then we can produce feed proteins from the seeds, which have a quite interesting content of proteins. The stove can be used for vapor, for steam, and for the thermic oil for the plant. But we are also able to use this type of raw material for other molecules like sugars, but also other type of antioxidants, for example. And today we have 400 hectares with 40 farmers which are involved in 3 years of experiments. This year, the third year of experiments, we arrived to consider a production of 15 tons per hectare of biomass and 1.5 tons per hectare of seeds, 1.2 tons per hectare of feed. And we have engineered specialized machineries in order to work on the soil, which in Sardinia is a stone soil, so a lot of problems for machinery. But today we are ready for a scale up for thousands of hectares. The hectares of land that in Sardinia are abandoned in the area of Sassari where we stay is about 70,000 hectares from 1982 to 2010. Sardinia is more than 200,000 hectares abandoned, and they are importing feed for 140,000 tons per year. So an industrial chain can in reality give positive effects on food and feed. Here you see the images of August when we collected harvested thistle and together with the farmers in order to inform them and giving all the information in order to have more land for these years. The agreement with them is that the crushing system, the crushing plant, will give back them the feed and we will take oil. In this way, we can have a shared system. And on this basis, we are creating a cooperation, a strong cooperation with the Farmers Association, which will be presented in a few days from now. Just to give you an idea of the plant, is 1 minute demonstration. This is the cultivations we have and this is the collection. Still, we have to collect what you see, the pappus we have to modify the machinery. Here is the labs of Matrica and the plant, the biomonomer plant. It's a huge plant. The first plant is 35,000 tons, and the other two about 35. So altogether is 70,000 tons plant. And we started in August, and we are finishing the startup of the plant. It's quite successful, I have to say, and we will have a demonstration just the 10th of October. We have a satellite event in Porto Torres, and some of you will be there, and I'm very pleased to host you in showing what we have built. Just to finish, here you see the milestones of this project since we made the joint venture with Universalis. We went from an agreement, a memorandum of understanding with the national, local authorities in order to present the project. We had the joint venture, we had the cooperation with local universities. We involved the companies on the local areas. Half of the investment returned on local areas. So this is a lot of money which gave jobs for the build-up. We made an agreement with the Farmers Association, specifically called Diretti, but we are in contact also with the others who are considering very interesting the model. And then we had the harvesting this year, which showed that we can go on with the industrialization of the chain. And finally, on 10 October, we will open the plant in order to show to who wants to see what we have built at the plant. This chain, this integrated biorefinery that we are building step by step. By the way, this is one site, the biggest one, but we are working on 6 different sites in Italy, introducing new technologies in the integrated chain of bioplastics. What has delivered this type of activity of many years of Novamont, but of Matrica, but of many other actors. Surely a significant private investment, which is today, looking at all the different sites, already spent 500 million euro. A lot of money in research, because putting together is about 200 million. And we triggered also projects with universities and research centers. And I have to say that the cluster of green chemistry is also, together with Mossi Ghisolfi, is a deliverable of this activity. And then the startup of an agricultural chain, which is without water, pluriannual, which anti-erosion, which can be useful also to study because of the resiliency that we need for the local areas, for dry areas. Reindustrialization of 6 different sites going on. New chemicals, or in any case, chemicals are not available at European level and with low impact processes like azelaic acid, pelargonic acids, derivatives, new oil extenders, butanediol, which is another project that we are implementing in another site. And then, not last, a virtuous chain of high-quality compost with extraordinary case of excellence, like Milan, which became the highest quality and quantity of organic waste collector. And this is also with the help of the team of the bioplastics teams and the team of the composters that in Italy made a lot of steps forward. The question is, how is it possible now with this type of deliverables to transform a case which is a case of companies, of universities, of the world of environment? Because one of the things that I think the project created, it was a common basis for worlds which were in different frontiers, and together we are working together around the project. What lacks is a real agenda, political agenda, which can transform this type of results in real jobs in a rapid way. We are ready to do this, and we hope to find the opportunity at European level and national level and local level to really make the trunk and to have the branches growing faster. Thank you.
Thank you. You can present directly the...
This is because Matrika...
Is it? They are both included. Yeah. So the third speaker, Giovanni Polcheni from Biochemtex.
Biochemtex, yes.
And we will have session, comments and questions from the floor just after you. Let's go.
Good morning. I represent Biochemtex, that is one of the companies of MG Group, Mossi e Ghisolfi, an Italian group that was and is one of the leaders in the production of PET, polyethylene terephthalate, worldwide. We entered in the project for the biorefinery because our aim was to produce polyethylene terephthalate starting 100% from natural and agricultural products. Today, 100% is from oil, and we, at the time, would transform this chain. During the studies, we have the possibility to understand that we can also give some innovation in the biofuels. Because the first step of this development is the ethanol, and the ethanol is a very good biofuel. From the second half of the last century, many people were studying the possibility to produce biofuels coming from biomass. But they choose the easier way, that was to use sugar and starch from food products. This was not a good thing, and today, this way is not possible because the competition with the food and the impact that this choose could have on the food chain could be dramatic. So, starting from about 10 years ago, many companies started to study the possibility to produce biofuels and chemicals starting from residual agricultural products or from specific type of trees that can be harvested on land not productive for food. We start in 2006 this project. We have a big research center, big related to Italy, with about 130 people, and we have an engineering company that is 100% dedicated to the technical development. We started in 2006 in labs, and 2 years after, we built the first pilot plant for the extraction of cellulosic material from the residual agricultural products. After 2 years, we decided to build a big industrial plant. This was a very big step, because in 2 years we goes from a pilot plant very small to an industrial plant. To define how big is, I can mention the investment that was about 200 million euro. This plant was built in very fast, and in January of 2013 we have the possibility to start up the plant, and today the plant is running. I can say that a few weeks ago we start up also a plant in Brazil that is using residual from the sugar industry, the bagasse, and from about 1 week is in production. This is the plant of Crescentino. Crescentino is a small town about 20-30 kilometers from Turin, and the plant is a real industrial plant. So with this plant we have an operating plant that can demonstrate the economics and the performance of this transformation. What is a few words about this plant? In this plant we use as raw material, as feedstock, wheel raw, and also it is possible to use a special type of cane, the usual cane that you can find close to the river. The name is Arundo Donax, and in the plant will arrive about 180,000 tons of raw material. This create about 40-50,000 tons of ethanol. Ethanol 99%, so practically pure alcohol. In this plant we produce also electricity, and we recycle 100% of the water, so we have also a biogas. This is very important because in the past this type of transformation to produce ethanol and biofuels was not considered economic because the cost was very high. But if we consider an integrated plant optimized, we can arrive to have the alcohol as a fuel, as a competitive price with the equivalent product from oil. What we did, practically we use the byproduct of the alcohol after the extraction of cellulose. We use this byproduct, the name is lignin, to produce electrical energy. The electrical energy produced is more than the energy consumed by the ethanol production, so we have an extra capacity of electrical energy that we sell to the grid. In the same way, we use all the biogas coming from the wastewater treatment operation. In this way, if we consider to have, obviously, the cost of alcohol is determined by the cost of the raw material, but we can subtract the revenues from the electricity sold, so at end we obtain a fuel that is competitive as far as regarding the price. This is the result that we attain today, but is an optimization that is continuously in evolution. When we start the plant, we have some figures considering a certain price of the alcohol. But after 4 years, we achieve the result to reduce practically to reduce at half the cost of alcohol. Now we are implementing a new idea and a new part of the project, so we are sure to arrive in 2 or 3 years to reduce at 30% the cost related to the designed in advance. Okay, a few words about the feedstock. As I mentioned before, we use essentially agricultural residues. Particularly in Italy, we use straw of wheat and rice, considering that the plant is in the center of the area of the rice crops. But we can use also corn and other kind of cereals. This is important for Europe, but I think is quite important for China and North American markets, because in that markets, and I can show after a slide, there are a huge capacity of straw. For the other, our process is very flexible, so for the a country with a particular climate like Brazil and South Asia, we can also use sugarcane bagasse and palm empty fluids. The second way to have the feedstock is use the famous Arundo donax, the miscanthus, that are a type of cane that can be cultivated efficiently in vast area that are not in which the land is not good for the food production. So we can create a chain with agricultural people that can be extremely convenient for them and good for the fuel production. I said that there are a lot of straw worldwide. You can see, and the more green is more straw. You can see that China have a capacity very big. The same are all the area of Siberia and the south of the United States. That means that what we can said for Europe can be multiplied 10 times for the rest of the world. Entering in particular in Europe there are potentially 16 million tons of biomass suitable for this use. That to transform that means build 30, 40 plant of second generation. That means produce 2 million tons of ethanol. To do that, we must invest about 8 billion of euro. The same thing can be considered for Arundo donax. There are many areas in the southern countries of Europe that can be transformed economically in area to cultivate Arundo donax. What means for Europe from economical and social point of view the development of the biomass transformation? If we consider only 4% of ethanol to substitute gasoline, we have about 11 million of tons. That means 100 industrial plants. That means 5.6 billion of euro of saving of oil import. That means 100,000 permanent new job created. That means also more than 100 million of man hours for plant construction. And the purchasing of equivalent of 100 billion euro of machinery, instrument, practically all equipment that can be produced in Europe. And the least but not less important, we can give to the agricultural sector an additional revenue of about 4.5 million of euro. So you can see that this development could be a real advantage for all Europe. I mentioned that we completed the first step of our project. The first step is this one, that achieved to us to produce ethanol. The process is very easy. In the first part, not so easy for as far as regarding the extraction of cellulosic material, but after we have the enzymatic transformation of cellulose in sugar, the fermentation, and from this point practically is a beer equivalent to a brewery. We have distillation and we produce ethanol good for biofuel. But as Mrs. Bastioli mentioned before, coming from the biomass, we can imagine a lot of chemical to be produced. And considering our technology, today we started with two important projects. One is using lignin not only to produce energy, not only to burn to produce energy, but we saw that is an optimum basis for the production of benzene, toluene, xylene, jet fuel, and phenols. This is the first part that closes our initial idea, because the polyethylene terephthalate need as raw material the xylene. And from this way, this is the first step for the plastic, for polyethylene from natural raw material. The second point is that with separation of C5 sugars with the GREG technology that is in a well advanced development, we can produce polyols and in particular glycol. So the glycol is the second raw material for the production of polyester. This project started about 8 years ago. I am an old engineer, so I am very prudent for the forecast, but I am sure that in 2020-2021 we can close this chain and produce plastic, the polyester, 100% starting from that kind of raw materials. From here, I think that considering also the transformation of ethanol, we can produce a lot of chemical products, practically the same products that the traditional refinery coming from oil can produce. This project and this development was done by our group. Our group is Biochemtex, investing about 450 million of euro. That for us is a very huge amount. And our company is a 100% private company. This project, we have effective help of many public institutions, and we hope that the same institution will be sustain also the new project and the development that can be very important for Italy and for Europe, because this is essentially a European project. Thank you.
So now it's open for discussion, question and comments. Yes, first one there.
Yes, please. Good morning. Good morning. My name is Achim Bönke. I come from DG Enterprise and Industry from the Chemical Industry Unit from the European Commission. And I have two questions. First, for Katja, I would like to have some more information about the energy source and how you are handling energy efficiency in the plant. The second question is for the colleague who presented Biochemtex. I was very impressed by the figure that would be based on bioethanol for the additional revenue for agriculture. How much would that be higher when considering not only bioethanol, but also the value of the other products that you presented? Thank you very much.
For what it concerns energy, this is a very important aspect because at the beginning we have considered the possibility to have a power station based on biomass of thistle. However, we changed the plan because we realized that the situation in Sardinia was totally different from what we thought. Because there is a surplus of energy. We have about 47% of renewable energy in Sardinia. And we have used last year 9 terawatt instead of 13 produced. So in reality, there is a lot of possibilities. So what we are doing is to work with the grid, and in order to have an efficient connection. And instead, we are working on the efficiency of the plant for steam and for the thermic oil, which otherwise, in Sardinia, we don't have methane. We have to use propane, liquid propane. So this is what we are doing at this moment. We are investing in 2 units for this part. So this is the way how we will complete the project. So the energy is taking the renewable energy that in Sardinia is a lot, trying to increase a bit the use because there is, we are speaking of energy, and this is a question to all of you. We are speaking of energy, continuously speaking of energy, but still I have also the heart of the Italian grid today as president, and unfortunately, we have another 7% reduction in the first 6 months of energy use. With some parties because of unbundling of the 2 development and energy, but a lot from crisis. So I think it's very important to revert on products because otherwise we will produce a lot of energy for doing what? So it's important to return to products and then to produce energy when we have the products and not vice versa. Thank you.
If I understand well your question, from this development, the agricultural world could have a big advantage, but the advantage is mainly due to the first step of the technology. Today, we produce fuel and we consider the market of fuel that can be implemented, in particular European Commission and the Italian government is pushing to increase the volume of the alcohol in the gasoline for the next years. Obviously, if we will be successful in total in develop new technologies to produce chemicals, all the chemicals from this kind of crops, obviously the agricultural people can have a real advantage because the volume will increase. And as I mentioned before, it's not necessary to change the use of the land. The byproducts from the present agricultural crops is absolutely huge to cover the needs of the next 10-15 years. So The advantage for agricultural people is coming from the development of this technology. Yeah.
Michael Narodoslavsky from the EPUA. A question to Ms. Bastioli. Did I understand you right that the yield is on thistles is about 1.2 tons a hectare in oil? Is that correct? So
the feed is 1.2 tons. The biomass, the dry biomass, is average in 3 years' time is about 15,000 tons plus 1.5 tons of seeds, and from that 1 something of feed per hectare.
and you're utilizing the biomass?
We are going to utilize the biomass for the steam and for the diathermic oil, and at pilot level we have also the possibility to transform in sugars. For example, we are able to produce 1,4-butanediol, but at pilot level. To make a plant from that, it takes some time.
Okay. And you have a 70,000 tons a year plant.
It's 70. The first plant is 35,
and you have
the other one is instead using esters. So you have to add other type of components in order to make the esters.
Yes, sure.
Okay, so it's altogether.
And you have all the area under contract.
Sorry?
You have all the area under contract that you need.
No. We at this moment we are working. The plant started with sunflower oil. Produced in a cooperative in France, crushing on the sea and coming from boat. We will never have 100% use of oil because of safety also reason. So we think to arrive to 50% of thistle oil. And this is compatible with the land and also with the use of other scraps. For example, Sardinia is also producers of vegetable oil, of olive oil, and there is residues of olive oil. There is reused oil, fried oil, which can be also used for the process. But thistle is very important because it's giving us a chain, and from this chain we can take a lot of other products. So it's a big research project on a dry crop, which can create a lot of knowledge. We have more or less all the big Italian institutions of research and universities working together with us in this big project of dry crops, which is far more than just feeding the plant.
Manage the impact of the biomass cost. Mass cost is more or less in Europe are between 30 and 80 euros per ton. So it can change rapidly all around the year, 1 point. Second point, when you shift from, I would say, marginal land with poplar, for example, it's rather easy, but as soon as you export proteins from the field, you have to re-inject nitrogen by fertilizer, so this would change completely the environmental balance of your agricultural production.
Okay, for the cost of the raw material, this is the reason why we try to study a project together with farmers. Because otherwise, as soon as we use the biomass and the price increase, then we don't have any possibility to really maintain a stable system for years. So the point to return back the feed for animals, it was the key point for farmers. Without the feed, they were not interested to go on. So they have a big problem. They have to import 140,000 tons. We never we can cover 140, but in any case, we can give a significant contribution. And this is the real point where they enter in the chain. If they do not enter in the chain and the relationship is industry, farmers, I will not see any possibility, especially in Sardinia, where the areas are very limited. We are working, trying to create cooperatives of young people. We are trying to make research on the models. So we cannot say everything is done, but this is the way how Coldiretti agrees to go in this type of direction. So this is, in terms of nitrogen, this is a very important aspect. We are working on two directions. One, Sardinia is among the Italian regions, the region which has the highest level of organic waste. So we are trying to reuse this type of raw material. We are working still with the type of machines to spread this type of product, because this is not easy. The other part is we are trying to see, for example, for the scraps of fermentation, this is something not done in Porto Torres in reality. We are studying in another site for 1,4-butanediol. We have from fermentation a lot of biomass, and we are trying to see how to reuse this type of biomass in order to give back the system. So we cannot have a full answer, but we are studying and putting research in this type of issue.
Well, from my point of view, as far as regarding the residual agricultural products, we take this for the moment from the market. From the present plant, we use 80% of the straw coming from the radio of about 100 kilometers. But to manage in better way the market, we import also from France and from other part of Italy. Now we are defining specific contract multi-years, so we give to the farmers a big advantage, because they know with a contract that they have a fixed price, fixed client for 10 years on the residual materials. And this, I think, is very important for the agriculture. The clear and certain basis. The same thing is for Brazil. The residual use of sugar cane is practically, now they are burning that product, and can implement the production of alcohol of 20-30% related to the sugar industry, using a product that is a scrape. As far as regarding the second problem, the dedicated area, specific for the Arundo Donax, we must consider that this type of cane, or the Alicanthus, the other tree, are able to live also in ground, on ground that is strongly polluted, and it can be used to clean the area. We have an advanced phase project in North Carolina, in which Arundo Donax is specifically used to clean a large ground. The same could be in Sardinia, in which there are the area around Portovesme, with the best great industrial development, now undevelopment, that are totally polluted. And the Arundo Donax in that area can help the regeneration of the ground. So obviously we can say we can use this way on all area. But there are in the world many areas in which the use of these specific plants can help also the reutilization of the ground.
So we have two different models when comparing those companies. One is based upon you are all using marginal land and polluted lands.
No. Yes.
It's. I think I don't know if it's the same. I think that in our case it's not the same because we start from chemicals and integrated technologies, and but. The point of the raw materials, we feel that we need to create a sustainable system locally. It doesn't mean that you don't have to connect with the rest, but you have to create economies locally. Of course, this means also that you have to dimension the plants that you have, which have to be compatible with the area. Okay, this is a very important point that I feel is something completely different from the normal economy, where you had to concentrate in one place the plants. And then I feel that if you start from the idea that bioeconomy has to be territorial regeneration, not just producing bioproducts, then I think it's so important to dimension the plant on the basis of what you can do. It doesn't mean 100%, but the significant part has to regenerate and has to be a startup for innovation. And on this basis, it's also important the rules of the local areas, because the question is, because Europe is not United States and not Brazil, and so we have an amount of biomass which is far more limited. We are not exporters of biomass. We have to use our biomass. The problem is how to use our biomass in order that we can take the highest added value from what we are doing, because the higher added value, and second, to maximize the biodiversity of the technologies, because today we don't know in bioeconomy what will be the real key technologies. So we need to have a lot of seeds all over in order taking advantage from the innovation, from the specificity of the local areas, and having different productions in different places, and then creating bridges from one biorefinery and another in order to create synergies. Because otherwise, if we look with the basis of big amount of products, etc., I feel that Europe will lose the train, because if then it's clear that the raw materials are cheaper, and then we can have also better scraps in South America and United States, how to compete? The only way we compete is with the efficiency of technologies, and then to avoid incentives which are unbalancing all the system. Because in this moment, if you consider the industry of chemicals and bioplastics, this industry is strongly penalized, for example, by biogas. Biogas, we have areas of Italy where we have corn, even in Sardinia, corn produced, and the water is not used in Sardinia, it's too expensive, but to produce corn for biogas, is possible because of the incentives. This is the type of system that, from my side, has to be considered. So the question of what to do in the local areas has to be considered not on the basis of the technologies available, but on the basis of the potential of this area. And this is true also for Europe, from my point of view. So it's very important to have many technologies, and here you see two different technologies, which are in any case very interesting and with a lot of interactions, by the way. However, when we consider land and farmers and agriculture, we have to be very careful about the quality of our life, and that pushing technologies will not create more, as it happened for biodiesel. We create more subsidies, more investments, more unemployment, and a disaster.
Thanks. Short answer?
No,
Short comment?
I agree. We are related to different focus on products. In that case, they produce chemicals with a high value, so it is possible to also have raw material more expensive, a little more expensive. In our case, especially for this first step, we enter in the field of the fuels. And in the fuels, the scale is very important. We need big production, big amount, big plants. So in our case, the real way is the use of residual of the agriculture.
I just wonder, the biochemtech process is very similar to the sunliquid process developed by Clariant, and I just wonder whether you did some benchmark with sunliquid.
I can say only one thing. Our plant is really, I show you the picture, and is producing, and you can visit also our plant. The Clariant plant is a pilot plant 4 meters for 3 meters. Another thing, we during the startup we had a lot of problems. I must recognize this, and we go ahead this problem. I don't know if the other companies will be so happy to overcome on the and what kind how long they need to go over this kind of problems. Essentially related to the handling of the raw material, because one of the secret is the flexibility. If you dimension and the plant only for a specific type of raw material, you are linked, hardly linked only to this product. If you have the plant that can use many, and the technology can use many different type of crops, you have more probability to become competitive. Obviously, the difficulties, in particular in the pre-treatment and the handling of the materials, become very higher if you must use a different type of materials. The straw is totally, the behavior of straw is totally different from the behavior of corn stalks.
We have to close the discussion on this first presentation. Obviously, we are going to be very late to go beyond the time limit. Take your time, because it's more interesting to have presentation and discussion rather than the break.
Okay, good afternoon. I'd just like to start by thanking the conference organisers for inviting myself and colleagues here today to talk to you about a project called Beacon, which is an EU structural funds initiative ongoing in the western part of Wales. I'm conscious that we're approaching rapidly lunch, and I don't want to keep you from your food, so I will keep this brief. So there'll be 4 of us presenting today. What we'd like to do is give you a very brief overview of the project so you can understand what we're trying to achieve. And then thinking about biomass flows within the project, each of the 3 academic partners will give you a very brief summary of their capabilities. And then finally, one of our industrial collaborators, Waitrose, will give you a perspective on sustainability from the retail sector. So what is Beacon? It's effectively a 5-year partnership between 3 universities in Western Wales, and those are Aberystwyth, Bangor and Swansea. I'll put a map up in a minute. But the central aim is, and indeed we think we've achieved this, is to establish a centre of excellence for biorefining in Wales. And the main focus of this centre is to link in with Welsh companies across the country and try and get them to adopt bio-based products across a range of sectors, and also embrace some of these greener technologies that we'll talk a bit more about in a minute. In terms of the strategic aims of the project, we're focusing on new job creation in industrial biotechnology, and indeed we have a team of about 120 dedicated researchers and support staff working on this project currently. And the aim of that is to try and build some critical mass so that we can stimulate inward investment by encouraging companies to either relocate into Wales or set up a new facility. And thinking about the commercialisation process, key to that is generating new intellectual property. One of our other key aspects of the project is promoting scientific excellence in Wales, which is one of the reasons why we're gratefully here today. So in terms of innovation, as I said, we're trying to encourage Welsh SMEs across a range of sectors to adopt these new bio-based products, whether they're drop-in replacements for current products or completely new products. We're very open in that respect. And in terms of sustainability, I don't need to talk about this because we're here to encourage companies to make the switch, and indeed our country to make the switch to the low-carbon economy. Okay. I said I'd give you a bit of geographical context. Wales is a comparatively small country. To give you a sense of scale, the distance between Bangor in the north and Swansea in the south is about 250 kilometres. In terms of the landmass, it's important to note that over 90% of the land available is set aside for the cultivation of crops, grassland and forestry. And part of what we're trying to do through the Beacon project is to stimulate growth in those broadly speaking, rural economies. So while the focus on job creation at the moment is in the industrial biotechnology sector, eventually we want to reflect that back and generate more jobs in the agricultural sector. So in terms of a UK perspective, there are a number of other complementary biorefining projects that are ongoing. Most of those are located on the eastern side of the UK, and they're based around existing industry clusters. I would say one of the unique points about the Beacon project is because we're split across 3 locations, we can cover a wide geographical area and link into, as I said, a wide range of different companies. And I don't want to talk too much about it, although there are a couple of slides later on in the presentation. We have within the project a very diverse set of skills going from plant breeding and crop cultivation through to biomass processing and conversion into products, not just fuels and chemicals, but bio-based materials. So in terms of the feedstocks we're using a wide range of both terrestrial and marine feedstocks, and we're very interested because, as I said, well, I didn't say, but most of the land in Wales is marginal and won't support food crop production. There are pockets of arable crop production in northeast Wales and parts of South Wales, and indeed parts of the northwest of Wales, but it's predominantly marginal land. So we, as with the other project speakers today, are trying to understand how you link that into to growth of crops onto marginal land without affecting biodiversity. We'll talk a bit more about the conversion technologies in a minute, as each of the institutions gives a very brief summary. But in terms of products, you know, we're interested in the same things that everybody else are. So chemicals, thinking about platform chemicals, lactic acid, succinic acid. Second generation bioethanol and biobutanol. In terms of materials, we have a strong interest in materials for both food and non-food packaging. We have a strong interest in biocomposite materials for linking into the construction sector, and we have an increasing interest in natural products, bioactive materials to feed into the cosmetics and personal care sectors. Underpinning all this is a need to understand both the life cycle assessment of some of these processes, but also the process economics involved in transforming plants into products. And increasingly, as other speakers have said, that's becoming very important for companies that we're collaborating with. I don't want to dwell too much on this, but there are a number of performance indicators which are being used to judge how successful this project is currently. And just want to talk about a couple of those. The Enterprises Assist is basically their collaborations with individual companies. So we're targeted to work with about 200 companies, and we're currently collaborating with just over 150, which is pretty good. We're about 4 years into the 5-year initiative, but we have aspirations to broaden out into other sectors, as I'll show you in a minute. In terms of jobs created, we're targeted to create 67 new jobs, which sounds rather modest, but we're starting from it's a fairly new industry in Wales. We've created 40 new jobs at the moment, and again, that's predominantly in the industrial biotechnology sector, and those jobs are held within the 3 academic institutions. What we are seeing is increasingly smaller startup companies setting up, and they are employing people to work with us on some of these projects. Okay, I don't know if you can read that. A very brief slide to show you. We engage with a wide range of companies, so thinking about conventional biotechnologies companies that there are in Wales, and one of the other speakers earlier alluded to one of those companies. But we also cooperate with companies across a wide range of other sectors. So going from forestry through to food, pharmaceuticals and waste management. Okay, so part of the remit, as I understood it, of this talk was to describe how we engage with our stakeholders and talk a bit about knowledge transfer. And again, I won't talk too much, but there are a number of mechanisms we have for engaging with our stakeholders. So we have two dedicated business development managers, one covering North Wales and one covering South Wales, and Mike's one of the BDMs who'll talk in a minute. And they provide the focal point, the contact point between the academics and the companies who want to collaborate with us. We strongly encourage one-to-one visits with companies. They come to visit us, and we go to visit them to understand their business models and some of the issues they have. We have targeted business breakfasts and workshops which are sector-specific, so we invite a panel of expert speakers and encourage as many companies operating in those sectors to come along and network and understand a bit more about best practice. We have an annual conference where, again, we're engaging with a wide range of stakeholders. We have a strong presence at trade shows and network meetings both in the UK and Europe. We have a dedicated website, as does everybody else. One other important thing to mention is we do get referrals from other projects we collaborate with. So key to this is signposting between the different projects. And if we haven't got the skill set to deliver the deliverables for a company, we can refer that company onto other projects. So the Commissioner for Research and Innovation earlier on did mention the Registars project awards, and I just wanted to very briefly touch on this. So this was instigated by the EC in order to showcase best practice in urban and regional development. It's held annually. For the 2013-2014 award season, Beacon was one of 80 nominations in 4 different categories, and we were shortlisted as finalists, one of 16 finalists in those 4 categories, and we subsequently won the Sustainable Growth and Jobs through the Bioeconomy category. It's great recognition for the large amount of work that both staff working on the project have been involved in and our industrial stakeholders. But I just wanted to take this opportunity to recognise the support of the Welsh Government through the Welsh European Funding Office, who've been very supportive of this project. Okay, I'm mindful of time, so again, I'll go through this very quickly, thinking about biomass flows within the project and the capabilities and expertise of the different institutions. So I'm going to very quickly cover the university, the research we do at Bangor University. Fairly diverse set of research areas. It's all focused on either biomass pre-treatment, biomass conversion or biomass extraction. Again, underpinning a lot of that is trying to understand the process economics of a lot of these low carbon technologies. So we have a range of conventional thermomechanical milling and sieving equipment that allows us to process the material prior to downstream treatment. We have a strong interest in both conventional fossil fuel derived solvents, which are still prevalent and the mainstay of the chemical industry. We have an increasing interest in green solvents, supercritical CO2, as one of the other speakers mentioned earlier. Again, those plant extracts go into a range of sectors, including the cosmetics and medical care. We have, as I said earlier, a strong interest in biocomposites production, whether it's for things like medium density fiberboard for the construction sector or thermal or acoustic insulation products. Again, going back into construction, it's about trying to valorise the residual fibre from some of these other processing steps. We've got an increasing interest in wet fractionation, so looking at things like shorter chain sugars and proteins, which we can incorporate into functional foods. We have an extrusion capability, so again, going back to our interest in composites, we have a strong interest in wood plastic composites, again, linking back into construction, but we also have an interest in the blending of biopolymers for tailor-made projects in food packaging. And finally, again, thinking about residual plant fibre, we have a strong interest in technology called pulp moulding, so that allows us to convert residual fibre into trays or packaging for both food and non-food applications. That's a very brief snapshot of what we do at Bangor. I'd just like to pass over to my colleague Steve Kelly from Swansea.
So good afternoon. I'm trying to carry on in the same flavour as Adam. So I'm at Swansea University, and this is a picture of Swansea University. It looks a bit like the Mediterranean. People have talked a lot about water, but in fact this is the wettest city in the UK, so we don't have much problem with water. And in fact, in the hills up behind Aberystwyth, the rainfall is the same as in the Amazonian rainforest. So It's huge. What I'm going to talk about from the Swansea perspective is our interest is using microbial sciences to get products using fermentation plants, but actually getting products out of the plants, but using microbes to make further products. And of course, we've heard about bioethanol and biofuels already. So our microbial experience allows us to do a lot of different things. So we're interested in biofuels and fermentations. So for instance, we have a lot of experience with yeast, and we also work with fungi and actinomycetes. We're also interested to use the modern biotechnologies of microbial genomics and bioinformatics to isolate, identify interesting enzymes, interesting pathways to new natural products, and also to try and understand how some drugs, in fact, interact with some of the targets can be found. So the whole of this work is located in this Institute of Life Science, which is at the centre, and that's the research arm of a medical school in Swansea. So I'm in a medical school and bring that sort of thoughtfulness to the project and looking for health products as well. So as I mentioned, we're interested in microbial natural products coming around here, and you can see here some streptomycetes, which produce a lot of different natural products. And so we're interested to see what we can do with, say, streptomycete or other microbes, growing them on the biomass and seeing what sort of compounds we can make. We're interested in the concept of biofuels and chemicals in an integrated approach, and obviously you want to extract the maximum value from the biomass. And we're interested in Welsh-relevant biomass, so things like these grasses and things that are bred at Aberystwyth and go on to Wimbledon tennis courts. And they're being bred for higher sugar levels, and we want to see what we can do with, say, a yeast, and then grow it on the grass extract, see what we can make in that sort of situation. And we have solved some of the problems. For instance, we've produced enzymes which allow now the yeast to grow on the carbohydrates in the grass. And we try not to compete with large-scale lignocellulose projects which are already up and running and doing other things elsewhere. We don't want to reinvent a wheel. So we're interested to make bioethanol from grass. We've been doing some of these experiments. Some of these things are now published and protected. And also we're then interested to say, what else can you do? Can you extract the proteins? Can you get other metabolites, fatty acids out of the biomass? You wouldn't want to throw them away to increase the value. And then what can the microbe do? So we can show that it could also do a biotransformation. So we can make a key intermediate in corticosteroid production from the yeast after the bioethanol production has been finished. So that's an example of the sort of activity we're interested in. We're interested in synthetic biology and metabolic engineering. So one of our projects, which is on the exemplar on the website, is that we persuaded yeast through genetic means to produce bioethanol, and then we can turn off a particular enzyme in a pathway which then accumulates squalene. Now, squalene is a product which is used in vaccine production. The squalene comes from sharks' livers, and that's unsustainable in the future. So we can have a co-production of squalene and bioethanol. So this is just a start, really, of a collection of products you could get out of this sort of process. And then we're interested in protein biochemistry and enzymology, looking at some of the enzymes that are key to some of the biorefinery approaches. And then lastly, we also are lucky to have the UK's Mass Spectrometry Centre in Swansea, so we can also provide a lot of analytical chemistry backup for companies if they're interested, as well as to other universities. So the Swansea activities are much the same as Adam has already mentioned. I won't go through too many of them again, but we produce IP, and then subsequently we produce publications. So doing good science through these sorts of projects, they're not mutually exclusive. You can actually build your science base through these sorts of projects which are also benefiting industry. So we have new processes and joint R&D. We have a very flexible approach, so we don't just say that this isn't biorefinery. We will advise companies on any aspect of biology and chemistry that they have an issue with or a problem. This helps us to get income in from Europe, from international industry, and also from the States. And we've created jobs and startups and helped startup companies, but not actually counted them as metrics. And then we take a very broad view. So, for instance, last Friday, we ran a joint event with the Guardian newspaper in the UK. So we had a masterclass on how to start up a microbrewery and develop it. And we can then assist all our microbreweries, which are springing up all over Wales. And we had a number of them came to our event on Friday. So we're prepared to assist companies in many different sectors. And at that point, I'll pass on to Aberystwyth University.
Unfortunately, I'm a man with no name. My name's Mike Morris. I'm Business Development Manager for the Beacon project based in Aberystwyth. And basically I've only got 4 slides, run through the research areas and the facilities that we have available in Aberystwyth. So looking at effectively the lab scale research work that's going off in Aberystwyth. Similar to Swansea, we have enzyme discovery, looking at novel sources. One of the sources is an unusual flock of sheep up in North Ronaldsay. They entirely live off seaweed, so their rumen is full of unusual bacteria that have been mined for enzymes. A range of analytical equipment for doing biomass characterization. We're looking at high throughput processing. We've got an array of robotics for processing biomass. Improving industrial biotechnology yields for production of platform chemicals, particularly interested in conversion of things like miscanthus to succinic acid, lactic acid as well. And looking at thermochemical conversion of lignocellulosic materials. We're also interested in natural products. I'm an analytical chemist by training. I've worked in pharmaceuticals and agrochemicals. So I'm particularly interested in developing downstream or improving downstream processes for extracting natural products and platform chemicals. 60 to 70% of the cost of any biorefining process is the extraction, downstream processing. Certainly when it comes to succinic acid, it's 60%. And lastly, feedstock development. 7-8 years ago, we were working in a government research facility called IGA, the Institute of Grassland and Environmental Research. This gives you an idea of why we are where we are. We are benefiting from the last 100 years of grass breeding, forage breeding within Aberystwyth. Over the last 30 years, the grass breeders have been breeding varieties of forage grass in perennial ryegrass for high sugars. The reason for this is that when the sheep and cattle eat the high sugar ryegrasses, the bugs in the rumen tend to convert those sugars in favour of amino acids. So you have more amino acids going into the hind gut for live weight gain. Because they've been bred for these high sugars and digestibility, they lend themselves nicely to biorefining. Adam showed the slide of the land area in Wales. 80% is crops and grasslands. That doesn't really explain it. 5% of the 80% is crops. 75% of the whole agricultural area in Wales is grassland. It's even more in Ireland. We have a different agricultural system in the northwest Atlantic compared to southern states of Europe. So we have a plug-and-play biorefinery in Aberystwyth. These larger scale equipment are available for companies within Wales, within convergence area. So a lot of our biorefining work has been based on processing these high sugar ryegrasses. Simple crude fractionation, put the high sugar ryegrass through a screw press, you get a liquid feedstock. All we're doing with that is what the farmer normally does in the field. The farmer normally cuts and leaves the sun to wilt the grass. We just harvest the whole grass, bring it in, put it through a screw press. You end up with a press cake that you can ensile. It naturally stores itself for feeding either into a biorefinery later or into your sheep and cattle We've never advocated taking sheep and cattle out of the equation. The liquor invariably is around about 10% water-soluble sugar. 80% of that sugar is fructan, a complex polymeric, polyfructose. Using continuous centrifugation systems and downstream processing systems, we can concentrate those sugars. We can separate out the lipid fractions, identifying as many different value streams as we possibly can. We've concentrated on steam explosion as pre-treatment for biomass. It's a standardized system. We've got pasteurization systems and methods of densification of dry feedstocks. We also have a unique biochar facility where we can process up to 0.5 ton of woody biomass and recover the bio-oils. And colleague Ed at the back is running a project with Aberystwyth Geography Department looking at cleaning up heavy metals from mine water runoff with charred grasses produced in that rig. And then on to the other aspects. I'm particularly interested in cross-flow filtration. We have 2 fairly small rigs, but they can be used for processing up to 1,000 litres of liquid feedstock. Improving the downstream processing, I think, is key to getting an economically viable biorefinery system. And we have steam in place, relatively small, 30 litre, up to 350 litre steam in place fermenters for doing our industrial biotechnology development. And with that, I'll hand over to Quentin from Waitrose.
Well, thank you. Well, I've got a challenge because you're just coming up to lunch and you've got a food retailer about to talk to you about things. So I'll try not to make it too appetising. But the strapline of this conference is about from concept to reality. And how do you move these slides on with this? Just enter. Right. The strapline of this conference is from concept to reality. And actually, Waitrose has delivered a reality through the Waitrose Way, which is what I'm going to talk to you about in a moment. But that concept started many, many decades ago and has taken a little while to deliver. But as I've been listening to the presentations this morning, I've become very, very aware that what we have tended to call sustainability or CSR or other words is in fact absolutely part of the bioeconomy. And all of these things are very, very circular and work very, very well. So I'm just going to dance quite quickly through the 4 pillars of our work. So championing British, I'll explain why we're saying championing British. Treading lightly, which is our environmental piece of work. Treating people fairly, which is our social work. And then living well, which is health and nutrition. So if we think about championing British first, that sounds like a curious subject to have at a conference that is being held in Turin. But in fact, what does it really mean? Because, of course, if we were an Italian company or a French company or a German company, we would be championing whatever nationality that was. Because it is about the indigenous agriculture, the sustainability of agriculture, and all of those things about local food, organic food. We are 5% of the UK supermarket share, but 25%, for example, of organic sales through supermarkets. So we play quite well into that space. That would be the same in any country. Where we practically engage, though, we are engaged with academia through, in fact, we sponsor the chair of sustainable agriculture at Aberystwyth University. There's the project we run with Bangor through sustainable packaging and grass and things like that. So there are very real touch points that work. Treading lightly is probably the bit which most people tend to focus on because it is the classic environmental piece: waste, water, carbon. And where we are with this, I'm not going to read that whole slide. You can read that if you have time. But basically, we are setting out to have the most the best effect on the environment around our stores and actually globally, the lowest footprint. So stores that we open now will be powered by biogas boilers, so the hot water would come from wood chip. We've had adventures in the past where we've done much more than that, where in fact all the refrigeration has been powered by biomass and things like that, and through absorption cooling from the waste heat from Stirling engines and the like. But very much the objective is to reduce our footprint, reduce our carbon, and we see doing that through increasing use of biomass and moving off-grid as being absolutely central to that. And there is a wonderful circularity about some of the other work, because we've heard people talking today about food waste. Well, food waste generates biogas. Actually, we generate the biogas. All of our food waste, which we obviously do our best to minimise, all of our food waste does go to anaerobic digestion after it's been donated to charities for the social part. That gas is potentially a vehicle fuel. Our latest fleet of lorries are very advanced in the way they are dual fuel. They've got all sorts of sexy aerodynamics and all the rest of it. But fundamentally, they are driving lorries now, which are something like, potentially, not always delivered yet, 70% lower footprint than a traditional lorry, which is absolutely fantastic. And of course, for a business like ours, which distributes a lot, it's very, very important. So there is loads of stuff there. I can talk to you for hours about sustainable fishing, blah, blah, blah. It's all there. I'll move on. Treating people fairly. Now, this is where you kind of wonder, well, where's the touch point between the bioeconomy and treating people fairly? And what does treating people fairly mean? Well, actually, the whole piece about working with communities in lower carbon economies, so where we've got things like the Waitrose Foundation. The Waitrose Foundation assists production in countries like Kenya and in places that are well, not UK. And of course, the point that's often made there is, well, importing food from afar, hasn't that got, really rather a bit of a negative impact on your carbon footprint and so forth? Well, actually, the answer is yes and no. I mean, it depends on the seasonality of that food. It depends on the transport mode and all the rest of these things. But one thing's absolutely for sure is that the support that's provided through that type of trade is replacing actually aid. So actually it's giving people the opportunity to earn that money. Actually, it doesn't have a big impact on the carbon, and everybody's basically happy. And living well is our piece where we are talking about wholesome and also sustainable diets. And again, there's a very big touch point here, because I think everybody knows that meat consumption is one of the big environmental aspects that people consider in their diet. Now, we only rear meat in the UK. It's all British, except for New Zealand lamb. I think we had a New Zealand speaker, someone from New Zealand earlier on, so we do have New Zealand lamb for quality reasons. But it is fundamentally UK-reared livestock. Now, those of you that know about livestock rearing will also know that animal feed is imported, that, all of these things is not all about just eating grass. If you're a cow, chickens will eat soya and so forth. So the other work that we're doing is to ensure that we are reducing the footprint of that. Obviously, inherently, because it is effectively local food for the UK, you've got the food miles thing going on. But actually, by increasing the amount of homegrown, and here I mean actually European-grown soya, or actually things like beans and legumes, high-protein soya substitutes, you can effectively reduce the footprint of that by cutting down on the amount of imported soya. And of course, immediately then, you're in the territory of actually you don't need to put so much pressure onto change of land use, which fundamentally translates into chopping forest down in a lot of cases. So the whole thing, I've been very, very strongly aware of the fact that what I've been talking about as sustainable and responsible retailing is in fact bioeconomical retailing. So thank you. It's time for lunch.
Any question from the floor? Any question from the floor? So before leaving, just know that the afternoon session will start at 2:15. so 1 quarter later, in order to have a lunch and a networking. And speakers for this morning, for this afternoon, have to upload their presentation during the lunch at the slide center, please, if some of them are in this room. So, thank you.
Yeah.
You have one question? Sorry. There is one question I miss.
Give up or? Yeah. Okay. Well, thank you very much for a very interesting presentation. My name is Erik String Christensen, and my question is about the protein circle. You said it in the last time, but I would like to ask, what about taking out the protein from the pasture, ryegrass? You have any experience on that for using for the protein, as you said last? Yeah.
Yeah.
One of the ways which we process the grass juice, the first stage is usually by rapidly pasteurizing. You can curdle out the protein. You then spin it through a centrifuge. What you end up with after that is protein crumb that can go straight to animal feed and a brown liquor. The brown liquor still contains the same number of sugars, same amount of sugars. You can either then take out those polymeric sugars and use them as a new, effectively, commodity chemical. I've spray dried the grass fructans. Very similar compounds, inulin from chicory, are used as soluble fibre in drinking yogurts. We are finding a similar response to the gut bacteria. Your probiotic bacteria respond well to grass fructans, short-chain grass fructans. So there's a number of potential commodity items that we can isolate from this grass stream. Protein is an easy one. We can hydrolyze all the sugars, make ethanol, grass beer. That's easy, but it tastes horrible.